Hi, my name is Anand Hardikar. I'm a professor and chair of physiology at Western Sydney University, Faculty of Health in Sydney, Australia. The interest was to try and find out something that is highly reproducible and something that anyone across the world should be able to replicate. We had a model developed on real populations from Australia, India, Denmark, and Hong Kong. We do work primarily on type 1 diabetes, but we also have projects that are funded in the areas of type 2 diabetes progression, and then we go and validate that in other populations in the world. So one of the focus has been trying to understand predictive biomarkers, and something that we started was to focus mainly on biomarkers that can change with time. So we look at biomarkers such as microRNAs, which can not only be biomarkers but also regulators of the disease process, and we try and understand how someone can progress to, in this case, type 1 diabetes. It has been almost 2 decades that we started using applied biosystems platforms in my lab. It started with the 7300, 7500 fast instrumentation, then the 7900. The data that we got from some of these platforms were really great. We've had the best reproducibility of any of the other systems that we have used. The assays that we choose for the microRNAs, they are stem loop primers, so they are highly specific to specific microRNAs. Than some of the other systems in the market, and that was a choice because we were very interested in looking at mature microRNAs, because it's the mature microRNAs that drive the biology. The other thing about sensitivity or specificity, I would say, that we've done dilutions where we take human RNA, cDNA, we dilute it with mouse cDNA, and then we measure a single copy gene. And we've seen for most of the assays, we get quite nice amplification until a CT value of 38, 39. So we do see that, at least with the TaqMan chemistry, we are very happy to use them for a large-scale discovery approach as well. So the Applied Biosystems OpenArray platform basically helped us to create a customizable chip of microRNAs, which was a 48 sample by 56 microRNA chip. That's the format we used to profile a range of these test samples. One of the areas that's really coming up quite a lot is multiomics. One question that we ask is, do we need multiomics every day, every time? One of the things that we have done is we have developed a dynamic microRNA-based risk score. We have augmented it using generative AI-based technologies and machine learning. And now we are working using other established platforms such as the Olink multiomics platform from Thermo Fisher. Generating multiomic data is probably way easier than it was 10 years before, but analyzing and integrating, harmonizing those data sets to generate useful information is really important. So that's something that is our focus in the coming year.